All right. So, question number 6 says, which of the following is a solution to 3x minus 2y equals 6? Now, first of all, how many solutions are there to 3x minus 2y equals 6? Jake? An infinite number. So no, we're not looking for the solution to this. We're looking for a solution to this. Okay? Our choices are 2, 3, 0, 3, 3, 0, and 4, 3. And in each of these, the first coordinate is the x, and the second coordinate is the. So basically what you're doing on this question is like checking your answer on the solving equations unit. You've got a specific value and you're going to plug it in and see if it works. In this case, though, instead of a specific value, you have specific values. You have a value for x and a value for y, and you're going to see if when you plug them in, you'll get the correct answer. So our equation is 3 times x. Well, x in this first expression is 2. Minus 2 times y, which y in the first one is 3, equals 6. Well, let's see. 3 times 2 is 6. And 2 times 3 is also 6. And 6 minus 6 is 0. So does that equal what it's supposed to? No. So we know that one's not the correct answer. Now our next option, same equation, but we're just going to replace x and y. Our second choice is x is 0 and y is 3. So I get 3 times 0, which is 0, minus 2 times 3, which is, and 0 minus 6 is negative 6, but I want positive 6, so that also doesn't work out, right? So the second one is not our answer. So then we move on to our third. Now again, same equation, so still 3 times x minus 2 times y. But we're going to change our x and y. What's x in this next one? 3. So I have 3 times 3 minus 2 times 0. So x is 3, y is 0. So I get 9 minus 0. Which does not equal 6, right? Which leaves us with only one option. So unless we did the math wrong on one of the previous ones, it should be the answer. But you should always double check because sometimes you guys do the math wrong. So let's double check and make sure this one does work. So what's my x value?
4.
What's my y value?
3.
So I have 3 times 4 minus 2 times 3. 3 times 4 is
12.
2 times 3 is
6.
and 12 minus 6 is
6.
Yay! It actually worked out. So this one is the solution, is A, not B, A solution to this linear equation. Stanton.
I think you have it on test also. Because
Nope, because I got it right. Same.
Exactly.
Same.
All right. Kaylee.
Number 9.
Number 9.
I know how to do this one, but it took me a long time.
I think I put them in the wrong order.
So this one says, find the rate of change of a line that passes through the points
Wait, are we going to have graph?
-6 to 5, -1. What's the question?
Find the rate of change of the line that passes. Find the rate of change of
I know, but what was your question, Cam?
Oh, are we going to have graph with paper on the test?
Not if these are the kinds of questions you have, because you really don't need graph paper for this. Now,
What if we have different ones?
if you want to bring your own graph paper in, you can, but I don't think there are any questions that really require it. All right. Okay, guys. Cole.
I can do that.
All right.
I can
You can bring your own graph paper if you want this, that's fine. All right. Guys, let's keep all 4 feet of our desk on the floor. Thanks for that support, Tanner. I appreciate it.
Yeah, stop pulling them around.
You guys were there for Judy's too, but
Yeah, no, it was the girls.
I saw all 4 in that back row. So,
awesome.
Like I said.
Okay. Remember, what is rate of change?
The rate that is gross.
Okay, guys. All right.
So what is your relationship?
Okay. It's more than that, though. And really, it's only a linear relationship if it's a constant rate of change. All right. But rate of change, the growing actually is probably a good way to start. It describes how y changes compared with x. Okay? Which means the most important thing you have to remember is that in this ratio, the top is the change in y.
And why is this second?
And then on the bottom is the change in x. If you got the wrong answer for this one, you may have possibly gotten the right numbers, but just put your x values on top and your y values on bottom. It's not interchangeable. Rate of change is talking about, if you think y is growth, okay, because it's up and down, right? So you're looking at how something grows over the course of whatever your input is. So we're changing x, we're choosing our input, and we're seeing how does y change as that happens. So our change in y goes on top, and to find change, what operation do you need to do?
You gotta do
Subtraction, right? You know, if you go to the store and you buy something, they give you change, they take what you gave them and they subtract the price, right? And that's your change, okay? So change is the difference between the original and the new value. So, what are our y values here?
2 and -1.
2 and -1. So, I can put 2 minus -1, or I can put -1 minus 2. It doesn't matter. You can do the first y value minus the second y value, or the second y value minus the first y value. The only thing you have to remember is, if I do the first one minus the second one, then on the bottom I have to do the first x value. Oops, sorry. I have to do the first x value minus the second x value. Whereas if I did -1 minus 2, then I would have to do 5 minus -6. So it doesn't matter which order you do it in, as long as you do the y values and the x values both the same. So 2 minus -1 gives us 3, because 2 minus a negative is the same thing as 2 plus a positive 1, right? And since I did the first value minus the second, I need to do the first value, -6, minus the second, 5, right? So what's -6 minus 5? -11, because I could change that to plus -5. -6 and -5 is -11. So I get 3 over -11, which is the same thing as -3/11. It doesn't matter whether the negative symbol is the number on the bottom or the number on the top, because if I divide a negative number by a positive number, what do I get?
A negative number.
If I divide a positive number by a negative number, what do I get? Okay, so no matter whether it's, now if we had done the reverse order, if I had done -1 minus 2, then I would have gotten negative 3. But then I would have had 5 minus negative 6, which would have been positive 11. So I would have had negative 3 over positive 11. But again, negative positive means it's going to be negative. So it doesn't matter which it's attached to, the top number or the bottom number. Either way, your fraction is going to have a negative answer. So it's negative 3/11.
If the 5 is positive, why is it negative?
Because it's minus, negative 6 minus 5. I said, but you know minus subtracting is the same thing as adding a negative. So it was originally minus 5. We just changed it. All right. Yes, Hannah. All right. Other questions? Other questions from the practice quiz? Tanner?
Yeah.
Number 5. So let's see. It says which set of ordered pairs can be used to graph y equals negative x plus 1. Now, in order to graph a linear equation, how many points is it good to have?
It's good to have 3.
Good to have 3, right? So they're giving you a set of 3 ordered pairs. But the problem is they've done their math wrong on some of them. So not all of them are actually solutions. So we're having to find which of these has all 3 of them are actually solutions. Now, if we start with option A, for A we have negative 1, negative 2, 0, 1, and 1, 0. Looking at the first of those, because you can only do one at a time. So let's do the first one. So my x value is, and my y value is. So plugging into the equation, what do I have? Who can tell me what it'll be once I plug it into the equation? Y, negative 2, equals
So you just plug them in.
all right, is that what most of you got?
No.
What did you get, Tanner?
Well, kind of just like guess on B, and I got it right. But
Well, it's probably not the best line of logic to go with, so let's not go with the random guessing option here. So, one problem with this right here. Y equals negative x plus 1, right? So y is negative 2. What is this? Which is x. But I'm supposed to have negative x. Guys, be careful. This is a really common mistake. If it says negative x, and the value you have for x is negative, then what do you really have there? A negative negative, which makes it positive. Okay, negative just means opposite, like, 2 and negative 2. Negative 2 is the opposite of positive 2, right? Well, the opposite of negative 2 would be positive 2. So if I have negative x, that means the opposite of x. And so if x is negative 1, then this should be positive 1. So be careful about when they give you a variable and it's negative. So here, this would really be 1 plus 1. Now, is that a solution?
No.
Negative 2 equals 1 plus 1? No. So that means A is out of the question, right? because the first point, -1, -2, doesn't work. Now, you might think, oh no, this is really long because I've got, 12 different values to check. Well, no, not really. Because if you look, -1, -2
Is also a D.
is also in D. So you can also go ahead and cross D off your list of possibilities because it also includes this point, which we already know is not our solution. Now, so A and D are both out. So if we move on to C, now we have the point -1, +2. Well, if I have this equation, y is now 2 equals -x. X is -1, so -x is +1 plus 1. So just plugging into the equation, y equals -x plus 1. Does 2 equal 1 plus 1? Oh, I'm a little scared sometimes. All right, so the first one's good, but that's only one, right? -1, +2 is good. Notice -1, +2 is also in
It's also in the B.
the B, right? Okay, so
The first one.
let's look at the next one. We have 0, 0. Well, plugging into my equation, y equals, so 0 equals -x. Well, there's no such thing as -0, so it'll still be 0 plus 1.
Oh, well.
Does 0 equal 0 plus 1? No, obviously not. So that means C is not our answer, which means we should have the correct answer be B. We already know -1, 2 is good because we worked that one out when we were doing C. The next point is 0, 1. So my y value is 1 and my x value is 0. Well, look at that. That's basically the same thing we just had, only I just make it 1 equals 0 plus 1 instead of 0 equals that. Does 1 equal 0 plus 1?
Yes.
Yes, so that one's correct. And then the last one I have is 1, 0, which means y, 0, equals -x, which is, nope, look at x. What's x here? X here is +1, so -x is -1 plus 1. Does 0 equal -1 plus 1?
Yes.
Yes, so all three values work out for this one, so that means B is the correct answer. Zach?
I don't really get the -x. I got it right, but I don't. You like multiply.
All right.
Well, if you get a negative.
If x is 2,
X has to.
guys, if x is 2, can a -x also be 2?
No.
I mean, just logically think about it. Can -x be the same thing as +x?
No.
Okay, if I want to make x negative, what can I do to x to make it negative?
Make it a negative by negative.
Multiply it by -1, right? So if I multiply this equation by -1, what do I have to do? Do the same thing on the other side, right? That's the basic rules of equality. So -1 times x is -x, and 2 times -1 is -2. So if x is 2, then -x is -2, right? Now, the reverse. Let's say x is -4. If x is -4, can -x also be -4? No, -x is the opposite of +x. It's not going to have the same value ever, ever, ever. Well, not ever, ever. If x is 0, then negative x is the same thing as x. But short of x being 0, x and negative x are not the same thing. In fact, they are opposites. Again, same reasoning. If I want to make positive x into negative x, I need to multiply by negative 1, which means I have to multiply by. So then I get negative x equals negative times negative makes it positive. So if x is a negative number, then negative x is a positive number. If x is a positive number, then negative x is a negative number. Negative just means opposite. So whatever x is, negative x is the opposite of it. So if it's positive, that makes it negative. If it's negative, that makes it positive. Tegan?
Because I was confused on it at first. What I did is I just added a 1 in front of the x.
You can do that.
I did negative 1 times negative 1.
There you go.
That's what I did.
That's good thinking. All right. Zach?
Well, how would you do it like negative x plus 1?
Well, if I have negative x plus 1, then I plug in whatever x is. So let's say x is 7. Well, then what would negative x be? So I'd have negative 7 plus 1. If instead, if I have negative x plus 1, but x is negative 2, then what would negative x be? So I'd have 2 plus 1. You just plug in the opposite of whatever x is, and that's your negative x. All right, other questions? Yes.
Number 10.
Number 10. So for this one, the graph of the line x equals negative 3 is, well, let's think about where does x equal negative 3? Let's see. Yes, Hannah.
It's right there.
That doesn't so much help.
I know.
So-
I know the answer. I know the answer.
So take 0 and then go to the right 3.
Left.
Oh, the left is negative 3. Go to the left 3 points.
All right. One thing that a lot of people mess up on is they think x is negative 3 here. Well, that's true. But so that's true, but
It's also.
that's not the only place where x is negative 3, because x being negative 3 means you move to the left 3. But you could move to the left 3 and also up some. Or I could move to the left 3 and also move down some. And it's still going to have the x value of negative 3 because we've still gone 3 units to the left. The easiest way to do these, though, is simply memorize. If your equation is x equals something, then it's going to be parallel to the y-axis. If your equation is y equals something, then that's going to be parallel to the x-axis. Because really, the x-axis is the line y equals 0. Because if we're on the x-axis, remember we talked about that's the y-intercept, because if you go through on the x-axis, the y value is 0, which means the entire x-axis, the y value is 0, right? So y equals 0 is the x-axis, which means y equals 1 is just 1 unit above, but parallel to that. Y equals 2 is 2 units above, but parallel to that. So all y equal lines are horizontal because they're all parallel to the x-axis. Whereas all x equal lines, well, if you think x equals 0 is our y-axis, right? Because we're going left none and right none. I'm just going straight up and down. So my x value is 0, which is why our x-intercept is where y equals 0. Or, excuse me, our y-intercept is where x equals 0. So if you think of it that way, if that's the line x equals 0, then all other x equal lines should run parallel to it, just negative if they're to the left of it, positive if they're to the right of it. So, for all of these equations, you should really basically just have memorized, if it's an x equals line, it's parallel to y, which means it's vertical. If it's a y equals line, then it's parallel to x, which means it's horizontal. All right. Other questions? Brian? Number 3. All right. This goes back to the stuff. Oops, why do you keep flipping back on me? All right. This goes back to the stuff we did on like Tuesday night, the week I was gone. This is graphing or using a sequence, writing a rule for a sequence. So if I have this sequence 8, 6, 4, 2, the first thing I had you do when we were working with sequences like this was what? Right, is put them into a table. Because this, you need to think of this not as how 8 relates to 6, but you need to think how 8 relates to 1. Because 8 is the first number in the sequence. 6 is the second number. 4 is the third number. 2 is the fourth number. And so on. And then that way, if it asks you to find the 72nd number, you're not having to go minus 2, minus 2, minus 2, minus 2, 72 times to figure out what it is. You want to find the relationship. What's the relationship between 1 and 8, and 2 and 6, and 3 and 4, and 4 and 2? Now, no, 1 minus 2 does not equal 8. The relationship between these is minus 2, which means for each time I'm subtracting 2. So if I'm going to get to the 72nd sequence, that 72nd term, that means I would subtract 2 72 times, right? 72 times. Times means multiply. So rather than doing minus 2, minus 2, minus 2, minus 2, we can just do minus 2 times 72, right? So this is the concept that, hey, since we have this sequence that is changing, it has a constant rate of change, this one is decreasing by 2 each time, then if I multiply minus 2 times the number it is in the sequence, then I will, the first term we've subtracted 2 once, right? The second term we've subtracted 2 twice. The third term we've subtracted it 3 times. But by the 72nd, we'd subtract it 72 times, right?
Yes.
So our y should equal minus 2x.
Would
But
y take the place of t?
the problem with that is, did I start out at 0? No. The reason that this isn't the entire equation is because I didn't start out at 0. I'm subtracting 2 each time, but I'm not starting from 0 and subtracting 2. So then all you have to do is look at, okay, 1 times negative 2 is not 8, it's negative 2. So what do I have to do to negative 2 in order to get 8?
Minus 10.
Oh, well, you gotta add 10 to get.
Okay, you need to add 10. So, guys, the repeated pattern is your constant rate of change. Your constant rate of change tells you what you're multiplying by. But that's not it, because guess what? This is not a direct variation equation. Remember direct variation? Y equals k times x. Well, this one isn't y equals k times x. This is y equals k times x plus 10. So this one's going to be a little bit different because, yes, I'm subtracting 2 each time, but if you think back, if we looked at our steps, if 1 is 8, what would 0 be? 10, right? So we didn't start with none and then subtract 2. We started with 10 and then took away 2 and then took away 2 more and then took away 2 more and then took away. So that's why it's going to be plus 10, because we had 10 to begin with and then I decreased it by 2 each time. And if you look, this equation will work for all of them. What's 2 times negative 2?
2 times negative 2 is
Negative 4, and negative 4 plus 10 is? And that's the y value for the x value too, right? So if I then wanted to find my 72nd term,
I know what you mean.
I could do, yes,
You do negative 2 times 72 plus 10.
exactly. And that would tell us what our 72nd term is. And it's a lot quicker than subtracting 2 72 times.
144.
All right. Now, guys, listen. Notice, though, on your answer selections, is negative y equals negative 2x plus 10 an answer?
No.
No. Why not?
Because they had no y. Why?
Well, they use t and n, but it's the same thing. T equals...
Because to get,
Guys, look at your answer choice. It is the answer. You know, you could replace them with t and n because that's what they use. T for the term and n for the number.
That's how you do it. It says which one describes it. So
Okay.
you have to give describe.
Now, guys, look at option C. T equals 10 minus 2n. It's just reverse order, guys. They put their minus 2x at the end and their plus 10 at the beginning. It's the same equation. I prefer that you learn to write it this way because when we get to slope-intercept form of the line, this will help more. But it's the exact same equation. You need to learn to recognize things even when they're in reverse order. Alright guys, if there were any you didn't get to, I did answer a couple that we didn't get to in class today during my second period, so you can watch their video if you need to.